Jai Hind everyone. In today's lecture, we are going to learn about graphs. What are the various kinds of graphs? Graphs are there in discrete structures. There are definitions and the terminologies that has been associated with graphs. So let's start. So first of all, the definition of graph. So what do you mean by graph? Graph is, you can say it is a kind of a generalization term which is used for linking of different kinds of vertices, or you can say it is a kind of a graphical representation of any kind of a set. So as we know, set is a kind of a collection of various elements or the objects. So how we can represent that particular set into a pictorial form? So graph is a kind of a pictorial representation. So it is a set which is having dots, which is having links, which is having edges, vertices and all that. So how we are going to represent the graph? Graph can be represented as this way. G is your graph here, and it will having the objects and the, or you can say it will having the elements inside it as your V, that is vertex, and E, that is your edges. So here we can write graph G, that will be equals to your set of vertices and edges. So here in this picture, you will be able to see that these particular circles are your nodes, or you can say these are your vertices. And what are these particular lines? The connecting line between these two vertices are known as your edges. So vertices can be named as numerous form, that is, you can say nodes, you can say dots, you can say vertex, whatever. Okay. Then what are the various kinds of graph and what are the terminologies that has been associated with them? So first of all, come to the directed and undirected. Before going to the kinds of graph or the types of the graph, we need to understand there are two terms that has been associated, that is directed and undirected. So when we are talking about the directed, so directed is like you are saying you are having a pair of vertices and there should be a kind of an edge which should be directing from one vertex to another. So what does it mean? That it must be having a kind of an arrow representation. So if I want to say that I want to go from A to B, then there should be a direction mentioned in that particular graph, that I want to go from point A to point B. So here in this graph, you can easily see that A is being directed to B. So if there are the vertices, kind of vertices, like if I am saying there are 4 vertices and you have to perform a kind of a connection between all these vertices, then you must engrave what is the path here that will be followed up. So if I am starting from this point, that is your A. Now if I want to go from A to C, this is your C. So there should be a direction mentioned here. Okay, this is your D. So A to B, there is a one direction, then A to D, there is another direction, and then B to C, there is a direction, and D to C. So in this particular graph, if I want to traverse node C or vertex C and starting from node A, then how I am going to traverse? So I would be having various kinds of paths available here. What are those paths? You can go from A to B, B to C. That is a one path. Another path is you can go from A to D and D to C. That is the another path. So basically, directed word means that this is a kind of a ordered pair of vertices which is having a kind of a direction from where you are starting and to where you are going. Okay. Now what is undirected? So basically undirected is what? Undirected is unordered pair. So it will not be having any kind of directions among them. The link is not having any kind of a direction. So if it is not having any kind of a direction, that you can go from A to B or B to B, B to A. whatever the way you want to traverse. So it will be treated as both ends, or you can say the direction will be uh, can be treated as, or can be traversed from the both direction. So that is your undirected word. Now what is loop? Loop is something like you can say it is a kind of you can say a path which is going or starting from a node and again traversing back to itself. So that is a loop. So loop is an edge which is having a direction but it is pointing to itself only. Okay, so that is your loop. So here if you can say there is a node A, and node A is directing what? It is directing itself. So it means it is creating a loop. So if you are starting from A, then where you are going? You are again ending up at A only. So it means if you are starting from a node and you are ending at that particular node only, and there is only one edge that you are traversing, it means you are traversing the loop. Fine. Now what is multiple edges? Multiple edges is if there are more than one edges between minimum two nodes. So if I want to say there are two nodes A and B, okay, and you want to go from A to B. So it is very clear that there should be a path from A to B, but there could be many more paths available. So if I want to say there is a path from A to B, like which is in this direction, there is another path from A to B, which is kind of a curve path, or you can say it is having a distance more than the distance which is I am getting from this path previously. So, but there is a path which is having an existence between these 2 points. So multiple edges is if you are joining the vertices, more than 2 vertices with more than 1 edges. That is your multiple edges. Now there are the types of graph. So first of all, start with the simple graph. Simple graph is what? It is a kind of a graph. Obviously the non-empty graph, which is having a, or you can say the set of vertices and edges among them, and that should be also in unordered pair. Okay, unordered means that it will be a kind of a graph which is not having any kind of a direction, so it will be your undirected graph. So here in this example, you can say if you are having 4 vertices here, 1, 2, 3 and 4, and all these vertices has been connected with various kinds of edges, and there are no any kind of a loop or no any kind of directions available in this graph. This is the simple graph. This is simple undirected graph. Okay, and you can say you can see easily here that there are no multiple edges available in this particular graph. So simple graph is something which you can say you are having kind of a nodes, and that particular nodes has been connected with edges with at least 1 or at most 1. So for simple, we are saying at most it is connected with 1 edge only. Fine. Now next is multigraph. So what is multigraph? Again, when I am talking about simple graph, the simple graph is what? That it has been connected with only 1 edge, but in multigraph there are multiple edges available between these 2 vertices. So in these 2 vertices, that is U and V, here you can see there are 2 edges, E1 and E2 present. So multiple edges between any pair of vertex, or there are edges from vertex to itself. It could be anything. So it is like you can say it could be like this also. So there is a loop here. So there are multiple edges which is associated with this particular vertex. Okay, or it could be a loop here also. Then this is also a kind of a multigraph. Fine. Next is your directed graph. Now what is directed graph? Once we have known about the word directed and undirected, then it is very easier to understand what do you mean by directed graph. So directed graph is a kind of a graph, or it is a kind of a set in which you are having the vertices, the edges, and basically those edges has been associated with a kind of a direction. So here in this particular example, you can see there are 3 nodes, and all these 3 nodes is connected with an edge, and that particular edge is having any kind of a direction. So if I want to traverse like edge vertex W, then what will happen here is that I am starting from, let's say, suppose U, this is my starting point. So I have the direction now. So whenever I am having the direction, I can only go in that particular direction. So I will go from U to V, then V to W. This is the only path available from U to W. You cannot go from U to W directly because the direction is pointing towards U, not to the W. So there is a difference between directed and undirected. So this is the directed graph, which is having vertices, edges, but the edges must have the direction associated with them. Okay. Now next is your complete graph. Now what is complete graph? A complete graph is a kind of a graph in which every pair of vertices is joined by exactly one edge. So what does it mean? That how or whatever the kind of nodes you are having, these nodes has been connected with one edge only. Okay, so this is not like this ki if I am having a node and only a one node will be available from this particular node, one edge is available. It doesn't mean like this. It means that whatever the nodes you are having, that vertices or you are having, that vertices should be connected with one edge to another particular node. So what does it mean if I am having like this 3 nodes, or in this example I am having 3 nodes here. So in this example, node A, C and B, all these 3 nodes has been connected to each another, but there is not a kind of a connection which is creating a double edge or a kind of a loop or a kind of a you can say multi edges. So there should not be a kind of multi edges in this particular complete graph. So complete graph is something which should not contain your loops, it should not contain any kind of multiple edges, but it does contain all these edges that should be connected with every other vertex. So it is your whatever the all possible edges that you can form in a graph, that will create a complete graph. Okay, so if I am having you can say if I am having like 5 nodes, so whatever the edges that you can create, so that each and every node can be connected to each and every other node. So I think this is the graph. Oh, sorry, this is the complete graph. In this particular graph, I am having all these edges that are connected with the other vertices. Okay, and every vertex has been traversed here with every other vertex, but they are not creating any kind of a loop here or any kind of a multiple edges here. You see, there is only a one path between these two vertex. There is only a one path between these two vertex. There is only a one path between these two vertex. Only one between these two, only one between these two. So this is basically you are finding each and every edges that can go directly to another vertex. Okay, that creates or make your complete graph. Now what is bipartite graph? Bipartite. So the word itself give you the meaning that you have to divide your graph into 2 sets. So bipartite is like kind of a partition here. Bi is your double and partite is kind of a partition. So double, you are actually creating a two partitions here of your graph. So bipartite graph is it a kind of a graph in which the vertex set can be partitioned into your two different sets. And how you are going to partition these two sets? You are going to partition these two sets exactly as there should not be any kind of an edge among your sets. So what does it mean? Let's take an example here. I am having, I am having kind of a graph. There are 4 nodes, 1, 2, 3 and 4. So in these 4 nodes, what I am having? I am having an edge from there to there to there, here to here and here to here. Now I have to create what? I have to create a bipartition of this graph. So how I am going to create? I am going to divide these particular graph into 2 sets exactly like this, that there should not be a kind of a connection among one set only. So there in the individual set there should not be any kind of a direct connection of these 2 vertex. So what would happen is, you can see there is a connection from A to B and A to D. Okay, so here I write my 2 sets in which my vertices are A, C, B and D. Okay, now here is a connection from A to B. So A to B, the connection has been made, and then there is a connection from A to D. The connection again has been made from A to D. Likewise, there is a connection from C to D, there is a connection from C to B and C to D. So C to D and C to B. Now what happens is, in this particular graph, you have divided your graph into 2 sections. So this is the first section, this is your second section. So this is your set 1, you can say, and this is your set 2. So in set 1, you can clearly see that there isn't any kind of an edge that is connecting A and C together. Okay, and similarly in the set 2, there shouldn't be any kind of an edge that is connecting B and D directly. So it means in this particular graph, I am able to bipartite or partition this particular graph into 2 sections exactly like this, that in set 1 and set 2 individually there should not be any kind of a connection. So that is your bipartite graph. So again, the definition, bipartite graph is kind of a graph in which the vertex set can be partitioned into 2 sets, such that you have to remember how you are going to partition your graph into a bipartite, such that the edges only go between the sets, not within them. So it should be, edges should be like this only, not like this. Okay, now this is the bipartition. Now what is complete bipartite graph? So complete bipartite graph is also a bipartite graph. You are again dividing your graph into 2 sets, but what is the difference? Now complete bipartite graph in which each and every vertex of your first set is going to be connected to each and every vertex of your another set. It means that you have to create your complete graph here as well as bipartition. So there is a you can say merging of your complete graph and your bipartite graph. So here in this example, you can clearly see this is your set 1 and this is your set 2. Same again by same definition that we have studied earlier about the bipartition, that in bipartition your vertices should not be having any kind of a link among them in your individual sets, but the edges should be connected with every another set. Now what is complete graph? Complete graph is that every node should be connected to another node in the graph. So here this particular set is having 4 vertex, this particular set is having 3 vertex. In here node A has been connected to each and every vertex available. So what does it mean? A is connected to P, A is connected to Q, A is connected to R. So in the last class I have already mentioned you about the degree. So if I want to calculate the degree of node A, then that will be 3. because there are 3 connections. Okay, now what will be the connections available from B? So B to P, B to Q, B to R. Likewise for the C, likewise for the D. Now this is not a kind of an directed graph, this is totally and purely on your undirected graph. So on undirected graph, what happens is you don't have to worry about the connections that could be made from either way, because in undirected graph, the connections can be calculated from either A to Q or Q to A. So this is your complete bipartite graph. Okay. Then in the next class, we will see the next topic. Thank you.